Hi guys, and welcome to weeks 14 through 16. So this is officially the last video for a start here in a module. We are going to actually combine these last 3 weeks together because the final exam is coming up December 6th through December 13th in a testing center. Information on the final exam is all up in Canvas, so you can read the review document. All the dates and specifics are there. So in lieu of trying to make 3 separate modules, it makes more sense to combine it and to have basically 1 week of new content and then give you some time to prepare, to wrap up ideas. As I said in the last Start Here video, I sort of push kind of hard throughout the semester, and so this gives you an opportunity to spend that time and, if you'd like, get the final exam done before the final exam week actually starts. So these weeks are combined into one. There's one more discussion board, one more homework assignment, and one more quiz. That would basically constitute week 14. And then weeks 15 and 16 are kind of there for you to prepare and review for the final exam, as well as also take into account the email that I sent regarding the opportunity for a review session for the final. If you choose to sign up, then please read that and complete the survey so that I am aware. So again, last homework and last quiz. This week you'll be focusing on sort of taking all these models that we've developed in this class and figuring out which model works best in which situation. And so you'll be working on sort of different modeling situations and picking the best function. The discussion board will be on rational functions and sort of talking about kind of things that are challenging and so on and so forth regarding asymptotes and whatnot. And then the discussion board wrap-up I'll go ahead and do now on Introduction to Rational Functions. So you have this appliance that costs you $500 and $25 per year. So if we start to look at average costs, now we're going to think about this as if we were able to take that $500 and sort of spread it out across the full time period. So of course the way you can think about this is if you were to buy some product and you were able to just keep it for 1 year, then that $500 was basically just there for you to, have something for 1 full year. But if you think about the same product stretched across time and you still just pay $500 but for 5 years, then clearly you got a better bang for your buck. You were able to pay less money and get more fulfillment out of that product. So if we begin to kind of look at how we would develop a model for this, we know that for just 1 year the cost is the $500 plus the $25 energy charge. So $525 for that year, but technically dividing it by the number of years you've owned it for, so in this case 1, doesn't change the fact that it cost you $525 to own that appliance for the year. However, when you own it for 2 years, you, again, just pay the base price once, and then you pay 2 $25 charges, one for the first year, one for the second year. So that costs you $550, but that is averaged out across 2 years, and that comes out to, on average, $225 per year. So that $500 got split up evenly between the 2 years, and you can kind of see that it was $25 for the first year, $25 for the second year. So that definitely, sorry, that should be $275, not $225. $275 for 1 year. Now for 10 years, if I jump ahead a little bit, same kind of idea, $500 base price, 10 years at $25 per year, $750 total. And now if I divide that out across 10 years, I see that it only cost me $75 per year to own that appliance, which is much more reasonable than $525 for the 1 year. Okay, well, so if I generalize this concept and I say I'm going to keep it for X years, then noticing the pattern, the coefficient on 25 is basically just the number of years. So if it's X years, it would be 500 plus X times 25, or 500 plus 25X. Now I have to divide that by the number of years, which in this case is a variable, so X years, and so now I've got a function. Okay, well, let's think about this. If I take $500, if this number of years I keep it for is sufficiently large, then this $500 keeps getting split up into evenly across all the years. However, if we look at the second term, so let me write this another way, 500 divided by X plus 25 divided by X, and the reason I can do that is because of the idea of common denominator, that whenever we add two fractions, as long as we have a denominator that's common to both of those fractions, we can add their numerators. But what this allows me to see is that in this second fraction I have 25x divided by x. Well, that just equals 25, right? Because if I take 25, multiply it by a number, and divide it by the same number, I end up with the number I started with. So we can see that over the course of X years, the 500 gets divided evenly, but no matter what, I'm going to pay $25 per year. Therefore, as time goes on, this $500 that I spent initially will appear to sort of level itself out across time, but the reality is that assuming this efficiency of this product doesn't change, I will still have to pay $25 for each year. So in the long run, I would expect that my average, especially over many years, let's say 500 years, that would mean the $500 is split up into 500 years, so that would cost me only $1 per year, plus the $25 that I pay each month. So if we graph this and we see that over time, now that's the red graph is this one here, we can see that over time, it's maybe a little bit hard to see, but the actual average yearly cost reaches $25. Now, if you keep that product for just like a fraction of a year, then you're not even paying $500 for a full year. You're paying $500 for a half a year, which $500 for a half a year would balance out to $1,000 for a full year. So keeping it for a very short time is very costly, but the longer you keep it, the more that $500 levels itself out. Now, if we compare that to a different product at $300 that may be less energy efficient, maybe costs us $50 per year, we can see that initially they're very kind of neck and neck. Of course, this one is going to be more expensive in the short term. However, we see that the orange curve, which is the representative of the $300 product that costs more per year to maintain, we can see that over the long haul, that's actually going to cost more because you're still going to have to pay $50 per year. But here you're only paying $25 per year, so eventually this one becomes a little bit lower. So that's it. Have a great week 14 through 16. Look forward to seeing you hopefully at the review session, and keep checking your email, for updates and things like that regarding grading and whatnot. But it's been fabulous recording these videos, and I hope you've enjoyed them. I will certainly be around. Feel free to ask questions as you finish the course and get ready for the final exam. So take care. We'll see you in the final discussion board.